Hello and welcome to the chemistry solution. This tutorial is on calculating enthalpies of reaction from enthalpies of formation. What is the standard enthalpy of formation? The standard enthalpy of formation is the enthalpy change associated with the formation of 1 mole of a compound in its standard state from the elements composing that compound in their standard states. And so, by definition, the enthalpy of formation of an element in its standard state is equal to 0. Now, in order to calculate the enthalpy of reaction, we can take the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactants. And in this case, N and M stand for the coefficients in the balanced chemical equations. Let's look at an example. Calculate the enthalpy change for the combustion of 1 mole of glucose to carbon dioxide and water. The first step when doing one of these problems is to write a balanced chemical equation. We know that for a combustion reaction, our compound is reacting with oxygen in the air and producing carbon dioxide and water. We then need to balance our chemical equation. The next step is to look up our enthalpy of formation values for the products and reactants on the table and place them in our equation. Remember that the enthalpy of reaction is equal to the sum of the enthalpies of formation of the products times their respective coefficients minus the enthalpies of formation of the reactants multiplied by their coefficients. Now, in order to do these problems, you would be given a table listing the enthalpies of formation of various different compounds. But in this example, to save space, I've listed only the values that we will need for this problem. The other thing that's important when doing these problems is to specify the state of your reactants and products, because the enthalpy of formation values differ depending on the state of a compound. So, for example, the enthalpy of formation of liquid water is different than that of the enthalpy of formation of solid water or gaseous water. You'll also notice that in my enthalpy of formation values, O2 is not listed. This is because the element oxygen exists in the standard state as a gas, and so the enthalpy of formation value is 0. And this holds true for any element in its standard state. Now let's plug these values into our problem. First, we're looking at the sum of the enthalpy of formation values for the products. Starting with CO2, I can see that the enthalpy of formation value is negative 393.5 kilojoules per mole. And I multiply this value by 6 because 6 is the coefficient in front of CO2 in our balanced chemical equation. And because I use the coefficients in my balanced chemical equation, this is why it's particularly important to balance your equation correctly. Also on my product side, I have 6 water. So I take 6, which is the coefficient in front of H2O, and multiply that by the enthalpy of formation value for water in its liquid form, which is negative 285.8 kilojoules per mole. This is the sum of the enthalpy of formation values for the products, multiplied by their respective coefficients. I then subtract the values for the reactants. I have 1 glucose, so I take 1 multiplied by negative 1260 kilojoules per mole. And then remember, I stated that the value of oxygen, because it's an element in its standard state, is 0. These are the enthalpy of formation values for the reactants multiplied by their respective coefficients. And now it's a matter of correctly putting these values into your calculator to come up with the correct answer. Be very careful keeping track of your negative signs and the parentheses so you come up with the right answers. And I think it's best to do these problems step by step, writing out the values you get for each part of the equation along the way. And this leaves me with an enthalpy value for the reaction of negative 2,816 kilojoules per mole. Let's look at another example. Calculate the enthalpy change for the following reaction. Ammonia plus hydrochloric acid goes to ammonium chloride. The first step is to check that you have a balanced chemical equation. and in this case our equation is already balanced. The next step is to plug our enthalpy of formation values into our equation. So we look up the enthalpy of formation values for the products and reactants on the table. On the product side, we have 1 mole of ammonium chloride, and the delta H of formation of ammonium chloride is negative 314.4 kilojoules per mole. On the reactant side, we have 1 mole of ammonia multiplied by the delta H of formation value for ammonia, negative 46.2 kilojoules per mole, and also 1 mole of HCl as a gas, which we multiply by its delta H of formation value, negative 92.3 kilojoules per mole. We then take the sum of the values for the products multiplied by their coefficients and subtract the sum of the values for the reactants multiplied by their coefficients, and come up with the delta H of reaction equal to negative 196 kilojoules per mole. Thanks for watching the chemistry solution. We hope you enjoyed this tutorial.